Friends, very good morning to everyone. We were dealing with the substitution reactions of alkyl halides, in which the carbocation is the intermediate form. In case of alkyl halides, another reaction which it can undergo is elimination reaction. Elimination in turn is a competition reaction for substitution reaction. When the heat energy is supplied in large quantity, then elimination predominates. When basicity of the nucleophile increases, elimination predominates. The elimination which the alkyl halides undergo is called as beta elimination. When I treat an alkyl halide with a strong base, it gives an alkene and hydrogen from the beta carbon and halogen from the alpha carbon, they move away as hydrogen halide and it creates an alkene. This is called as beta elimination reaction. This reaction, like that of substitution reaction, follows two types of kinetics. First one is the second order kinetics. Some alkyl halides undergo or follow the first order kinetics. To explain the difference in this kinetics of different alkyl halides, two mechanisms are proposed. They are E2 mechanism and E1 mechanism, which stands for bimolecular elimination and unimolecular elimination, similar to that of the substitution reactions what we have seen. In both the mechanisms, the elimination of hydrogen halide takes place, but the timing of the bond cleavage and bond formation differs. This carbon to which the halogen is attached is alpha carbon, and the adjacent carbon to this alpha carbon is beta carbon, and the base take out the proton and halogen leaves away and halogen combines together to lose as hydrogen halide and a double bond is formed. As the proton is eliminated from beta position, it is called as beta elimination reaction. Coming to the E2 mechanism, it occurs in a single concerted step. The base abstract the proton which loses its electrons to the carbon forms the bond with the adjacent carbon which is partially positive due to the electronegativity of the halogen. As and when the bond forms between the two carbons, the halogen gets removed to give an alkene and the H plus combines with OH minus, that is the base, to leaves as water molecule and bromide ion. The rate of the reaction is dependent upon both the concentration of the alkyl halide, that is the substrate, and the base. In this reaction, it occurs in a single concerted step. Bond making between the two carbons, bond breaking between the hydrogen and carbon, and bond formation between H and OH, and bond breaking between carbon and halogen takes place simultaneously in a single step. The characteristics of the C2 mechanism is that it follows second order kinetics. It occurs in a single concerted step. And the rate of the reaction is like this. Tertiary alkyl halides are more reactive than secondary or more reactive than tertiary alkyl halides. And the strength of the base plays a very important role. The concentration or strength of the base, as it increases, the rate of reaction also increases. Better the leaving group, better will be the formation of the product. The solvent which favors E2 mechanism is polar apritic solvent. It follows second order kinetics in which bond formation and bond breaking occurs in a single step. The evidences are given in support of this mechanism. The primary sequence of the reaction is that the proton is abstracted from the beta carbon from the base, and that is found to be the rate determining step. And this has been proved by primary isotopic effect. What is this primary isotopic effect? If I take ethyl bromide and treat with a base, I'll get corresponding alkene. In this ethyl bromide, the methyl group hydrogens, if I replace by its heavier isotope, that is deuterium, and carry out the same reaction in the presence of the base, it also gives an alkene. If suppose the ethyl bromide takes 2 hours to complete the reaction, the deuterated ethyl bromide takes 4 hours to complete the reaction. Means, as deuterium is the heavier isotope of hydrogen, this takes more time for removal. What it indicates? That the primary step in the reaction is removal of a proton to form a carbanion. And again, it is shown that tertiary alkyl halides are more reactive than secondary or more reactive than primary alkyl halides. Why is it so? When it is tertiary alkyl halide, there are more alkyl substitution. More is the substitution by alkyl groups, more will be the stability of the transition state. The double bond which is partially formed in the transition state, which has more substitution, that alkene, it has lower energy and thus it reduces the energy of activation for the reaction. Hence the reactions become faster in case of tertiary alkyl halides. And as it occurs in a single concerted step, there is no rearranged product formed. These are the evidences which are given in support of the mechanism of the elimination reaction. Stereochemistry of elimination plays a very important role, and this elimination reaction is found to be regioselective. It is said that it favors Zaitsev's product and it follows Zaitsev's rule. What is this Zaitsev's product? If there are two beta carbons, here also this is alpha carbon, this side one carbon, this side another carbon, two beta carbons. The proton can be eliminated from the right side carbon and also from the left side carbon. If it is eliminated from the right side carbon, I will get corresponding 1, 2, 2 trimethyl alkene. And if at all it is eliminated from the carbon at the left hand side, I'll get disubstituted product. The major product is the trisubstituted product and the minor product is the disubstituted product. Here, Zaitsev's, that's why it is selectively abstracting the proton from the carbon which is on the right hand side rather than the left hand side. This is called as regioselective reaction. Sidesef has observed this for the first time and he gave that the major product which is formed is the one which is having more substitutions. The alkene which is formed in the major amount is that alkene which corresponding to the removal of hydrogen from that beta carbon which is having the lowest hydrogen substituents. This carbon has two hydrogens and this carbon has three hydrogens. Removal of hydrogens occurs from that carbon more easily from lowest having lowest hydrogen substituents. It has two. It is having lowest. It is having three. That's why the major product is the tri-substituted product. Why this tri-substituted product is formed in more quantity? Why this has become the major product? It is because of the fact that more the substitution by the alkyl group, more will be the stability of the alkene. It is attributed to the various factors including hyperconjugation and inductive effect. It is said that each alkyl group which is substituted on this alkene, it stabilizes the alkene by 6 kilocalorie per moles through hyperconjugation. Hence, more the substituted product, more will be the formation. This is Sidesef's rule. And it is not only regioselective, it should have anti-proliplanar geometry for the reaction to occur. The hydrogen and halogen should be on the opposite sides. That is called as anti-periplanar. If hydrogen and halogen in this case are on the same side, then they are syn-periplanar. In syn-periplanar, the reaction do not occur easily. In anti-periplanar geometry, the reaction occurs easily. Why is it so? It is said that when it is in anti-periplanar geometry, the molecule exists in staggered conformation. If it is in this syn-periplanar geometry, it will be in the eclipsed conformation. As we know that staggered conformation has larger torsion angle of around 180 degrees. Hence, the interaction between the hydrogen and halogen will be less and it will be the most stable conformation. In case of syn-periplanar, it will be in the eclipsed conformation and the torsion angle is 0 degrees. Hence, it has more interaction and that's why it is less stable. Thus, it should have anti-periplanar geometry for more stability. If I take the example of dehydrohalogenation of cis 1-chloro 2-methyl cyclohexane. It can exist in two conformation. One is in staggered conformation in which the leaving group and the proton and the beta carbon are having anti-periplanar geometry. In this second one, this as having non-anti-periplanar geometry. In first case, we have two hydrogens and the corresponding two beta carbons. This is also beta carbon and this is also beta carbon. This beta carbon hydrogens can be abstracted and this also can be abstracted. When this gets abstracted, the hydrogen which is this from this beta carbon and halogen, it gives a di-substituted product. This is one substitution on this one of the carbon of the alkene and this another substitution. That's why it is di-substituted. This hydrogen and this halogen are having antiprotonal geometry. This is from the other beta carbon. If this gets subtracted, this gives a tri-substituted alkene. This is alkyl group, methyl, and this is another alkyl group. Two substitutions over here and another substitution over here. Thus, it's tri-substituted alkene, and this is the major product which is formed. This is the stereochemistry of E2 elimination reaction. Next class, we can deal with the even mechanism. Till then, have a nice day. Thank you.